For this last exercise in this chapter, we're going to do something a little different. We're going to demonstrate how the for each loop is implemented rather than work another problem with the for each loop. So let's go ahead and get started. The first thing we have to do is we have to import another class into our program that we're going to need, and that's called the iterator class. I mentioned earlier what iterators are, and we're going to look at another example in a moment. But to use them, we have to import them into our code, so that's the first thing we're going to do. Now let's create an array list. We'll call it numbers, just to keep it simple. And we'll work with integers. Then we'll write a for loop that runs from I equal 1 to 10. And we'll add each I into our array list. So now we have an array list of 10 numbers 1 through 10. So the for each loop works like so. I'm going to use in here. So let's compile and run that program, and then we'll talk about how it works underneath. So we're going to compile, then run it. And there's the numbers 1 through 10 coming from the array list using a for each loop. Now, we can write a program that simulates how the for each loop works internally. And here's how we do that. It's going to be a regular for loop, and it's going to work like this. The first thing we do is create a loop control variable that will be our iterator object in, and we get it by calling a method from our array list called the iterator method. The iterator method returns an iterator, and an iterator is an object that will allow us to move through an array list or any collection element by element. And the way it works is it looks to see if there is another object in the collection to work with. That's what hasNext does. HasNext is a Boolean method that returns true if there is another element in the collection. And once it gets to the end of the collection and there's nothing following the last element, then it will return false. We don't have to increment or decrement or modify in any way because hasNext will be checking the next element after the one we're currently at. The iterator then is called with a method called next. Next returns the next object. Actually, you can almost think of it as the current object. Well, it's probably better to think of it as when we go into an array list, for example, we have a pointer. At the beginning of the for each loop, or the iterator, it's pointing right before the first element of the array list. When the next method is called, the pointer then moves to that first element, or the next element, depending on where you are, and then that is what gets returned to num in this statement that you're looking at. So next returns the next element in the array list and puts it in the variable num. And then we can simply work with num like it's a regular variable value. So we'll print it and then move on. So internally, a for each loop looks very similar to a for loop. In fact, it is a for loop, but it's so much easier to write a for next loop. Let's do that again just so you remember how it works. Like so. So this for loop using the iterator is equivalent to this for each loop, but the for each loop is much easier to understand and easier to implement. Let's build the program and run it to make sure everything works correctly. So we should see 2 sets of 10, and we do. So those 2 loops are equivalent. The for each loop is the preferred way to write it, but this first for loop demonstrates how the for each loop works internally. And it works internally by creating an iterator object and then testing to see that there are more elements in the collection by calling the hasNext method. So that wraps up this discussion of alternative control flow structures. Now we're ready to move to the next chapter where we're going to talk about text file processing.